Om Shri Sai Ram. Dear students, welcome to the fourth video on triangles, which is the second chapter on 10th standard mathematics book 1. In the previous videos, we have discussed the conditions for similarity of polygons, Thales theorem, its converse and corollaries, and few criterions for the similarity of triangles. Let us see what we are going to discuss today. Look at these three diagrams, three triangles. Their areas are given. First one 60 centimeter square, second one is 540 centimeter square, and the last one is 15 centimeter square. Assuming that these triangles are similar, if BC is 8 centimeter, are you able to find out QR and YZ? Observe the ratios of areas. Here 60 centimeter square, 540 is 9 times of 60. So second triangle, area of second triangle is 9 times the area of first triangle. Area of third triangle is 1/4 of the area of first triangle. So if you are thinking it is 8 centimeter, then QR is 9 times of 8, that is 72 centimeter, and YZ is 1/4 of 8 centimeter, that is 2 centimeter. So sorry to say, you are wrong. So if the areas of triangles are in the ratio 1:9, then their corresponding sides are in the ratio 1:3. So here QR is 8 3 is a 24 centimeter, and YZ here ratio is 4:1. Therefore, the corresponding sides are in the ratio 2:1. That is 4 centimeter. YZ is 4 centimeter. So before that, let us look at the answers for the questions given in the previous video. First question is whether the given set of triangles are similar or not. So at the first look, you may think that these two triangles are not equiangular. Here one is 80 degree and 70 degree, here 80 degree and 30 degree. But if you find out the remaining angle using angle sum property, angle F becomes 30 degree, that is 180 minus 80 plus 70. Here angle P becomes 70 degree. Therefore these two are equiangular triangles and hence they are similar. Look at the answers. Here look at the ratio of the sides. This is 2.5 centimeter and this is 5 centimeter, that is 2 times 1:2 ratio. Here this is 3 centimeter, here it is 6 centimeter. These two sides are also in the ratio 1:2, and one of the angle is 80 degree here. Here also one of the angle is 80 degree. But look at the position of the angle having 80 degree. Here 80 degree is opposite to 3 centimeter. Here 80 degree is not opposite to 6 centimeter. We don't know what is the measure of angle D. If these two are isosceles triangles, then we can say that they are similar triangles. But figures looks like they are not isosceles triangles. But sometimes what happens, the figures given in the questions may not be according to the scale. So let us assume these two triangles are not isosceles triangles, and therefore the angle corresponds to A is angle D. So they are not equal here. Assuming that they are not isosceles triangle, the corresponding angles are not equal, or the ratio of the corresponding sides are not equal. Therefore the triangles are not similar. So look at the answers. So now go to the next question. In the figure, altitudes AD and CE of triangle ABC intersect each other at point P. Show that three sets of triangles are given. We have to show that they are similar. Look at the first question. Triangle AEP. Triangle AEP is here. Triangle CDP. These two small triangles. So we can separate, we can take out those triangles and draw it separately. So to prove that they are similar, we need at least two pairs of equal angles. So we have a pair of right angles. Angle D is 90 degree here. Here angle E is 90 degree. We have a pair of right angles. So when you look at the picture, immediately we can find out a pair of vertically opposite angles. Angle APE and angle CPD. Their vertically opposite angles are always equal. Therefore we have two set of equal angles. The triangles are similar. Look at the second question. Triangle ABD. ABD, a right angle triangle with angle D is equal to 90 degree, and triangle CBE. CBE, it is also a right angle triangle with angle E is equal to 90 degree. I will separate the figure. So those two triangles have a pair of right angles, one pair of angles over, then vertically opposite angles. Do you think? No. So here this angle APE, it neither belongs to the triangle ABD, it nor belongs to triangle CBE. So therefore it is not considered. Then which angles can we consider? Look at angle B. Angle B is common for both the triangles. So in these two triangles we have a pair of right angles, that is angle E is equal to angle D, and a common angle B. So therefore the triangles are similar. So last pair, triangle AEP. AEP, this small angle, and it is also right angle triangle, right angle at E, and triangle ADB. ADB is also a right angle triangle with angle D is equal to 90 degree. In all these set of triangles, we have right angles. And another set of angles, angle A is common for this small triangle, and for this big triangle, angle A is common. So therefore we have two set of angles, equal angles, and the triangles are similar. Look at the next question. A vertical pole of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower casts a shadow of 28 meter long. Find the height of the tower. So you may know that the light rays produce equal angle when they create shadow, assuming that sun is far away. This is a shadow. So this angle, take any objects at the same time of a day. So all these angles are equal. They form same angles. So in other words, if you look at the tip of the objects at any specific particular time of a day, from the end of the shadow, so we can notice that all the objects are equally elevated. So that's meaning is same. This angle will be same as this angle if this is the shadow of this object and this is the shadow of this object. So using that we can solve this problem. So let us assume a vertical pole of length 6 meter. AB is the pole, 6 meter, its shadow is 4 meter, and DE is the tower, its shadow is 28 meter. So it is vertical pole, therefore angle B is equal to 90 degree here. So no doubt the tower is vertical to the ground, perpendicular to the ground. Therefore, if you assume a triangle here, then angle E is equal to 90 degree. So we have two right angles and they are equally elevated. Therefore, angle F is equal to angle C. So the triangle ABC and the triangle DEF, they are similar. Now write the ratio of the corresponding sides. So you can take ED by AB, which is equal to EF by BC. or you can take AB by ED is equal to anywhere. So AB by DE is equal to BC by EF. So substitute the values. So DE by 6 is equal to 28 by 4, 4 sevens are, and 6 sevens are 42. So height of the tower is 42 meter. So now go to the theorem number 2.6. So which explains the relation between the areas of similar triangles and their corresponding sides. So read the statement and by the statement. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. In other words, the areas of similar triangles are proportional to the squares of their corresponding sides. So let us prove this theorem. First, the hypothesis, you have to identify which is the hypothesis part and which is the conclusion part. The ratio of the areas of two similar triangles. We have to assume two similar triangles at first. So let ABC and PQR be the similar triangles. Then data is the explanation of the hypothesis related to diagram or the explanation of the diagram. So the data is triangle ABC and triangle PQR are similar triangles. That means angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. And also the ratio of the corresponding sides AB by PQ is equal to AC by PR, that is equal to BC by QR. Then the conclusion part, what we have to prove? The ratio of the areas, triangle ABC, area of ABC divided by area of PQR, the ratio of the areas of similar triangles is equal to square of the ratio of their corresponding sides is equal to AB square by PQ square. You can write AB square by PQ square or AB by PQ whole square. So that we have to prove AB by PQ whole square, or that is also equal to BC by QR whole square. That is also equal to AC square by PR square. So let us prove it. So it needs to find out the area of triangle. To find out area of triangles, we need the height. So construction. So draw the perpendicular for both the triangles. Let AM is perpendicular to BC and PN is perpendicular to QR. Heights of the triangles. Now write the areas. So the construction is AM is drawn perpendicular to BC and PN is drawn perpendicular to QR. So now write the areas. So area of triangle ABC, half into base into height, half into BC into AM. So half into BC into AM. So write this area of second triangle. So area of triangle PQR, so which is equal to half into base is QR and height is PN. So divide the areas. So half get cancels out. So you get BC by QR and AM by PN. You can write it as, so BC by QR as one group and AM by PN. So AM by PN, one group, BC by QR, another group. Their product is equal to the ratio of the areas. If in the place of AM by PN, if we have BC by QR, we can come to the proof. So let it be 1. Let us take this triangle ABM, and this triangle PQN. So you know that angle M is equal to angle N. According to our constructions, both are right angles. Angle B of first triangle is equal to angle Q of second triangle. Why? So because it is given, angle A is equal to angle P in triangle ABC and in triangle PQR, Angle A is equal to angle P and angle B is equal to angle Q. Therefore, angle B is equal to angle Q. So that means these two triangles, triangle ABM and triangle PQN, they are similar. So let us write it. So triangle ABM is similar to triangle PQN. So according to AA criterion, we have two pairs of equal angles. Angle B is equal to angle Q and angle M is equal to angle N, right angles. Now write the ratio of the corresponding sides. So we can write AB of first triangle divided by PQ of second triangle. So which is equal to BM by QN is also equal to AM divided by PN. So AM divided by PN, which is equal to AB by PQ. Look at here, AB by PQ is equal to BC by QR. If we take it as 2, okay, if we take it as 2, observe 1 and 2, AB by PQ is equal to BC by QR. Here AB by PQ is equal to AM by PN. Therefore, comparing 1 and 2 using the axiom 1, things which are equal to same thing are equal, we can write AM by PN as BC by QR. So in the place of AM by PN, we can write BC by QR. So that is equal to BC square by QR square, or BC by QR whole square. So as AB by PQ is equal to BC by QR is equal to AC by PR. So we can write this result. So let us look at these steps again. So construction, AM perpendicular to BC and PN is perpendicular to QR. Then proof, take the area of triangle ABC, half into base into height, half into BC into AM. Area of triangle PQR is half into QR is the base, PN is the height. So half get cancels out, BC by QR into AM by PN. Let it be 2. It is taken as 1, let it be 2. Now consider the small triangles. Triangle ABM is similar to triangle PQN because angle B is equal to angle Q and angle M is equal to angle N is equal to 90 degree. The triangles are similar. Write the ratio of corresponding sides of small triangles. So we can write AB by PQ is equal to AM by PN. Let it be 3. So compare 1 and 3. So in 1 we have AB by PQ is equal to BC by QR. Here we have AB by PQ is equal to AM by PN. So therefore AM by PN is equal to BC by QR. So here in the place of AM by PN, if we substitute BC by QR, so we get the result. So proof is continuing. So from 1, 2 and 3, this is 1, AB by PQ is equal to BC by QR, here 1. It is 2, areas of the ratio of the areas of triangles is equal to BC by QR by into AM by PN. Here we have AM by PN is equal to AB by PQ. So from all these three equations, we can conclude that area of triangle ABC by area of triangle PQR is equal to AB by PQ whole square is equal to BC by QR whole square, that is equal to AC by PR whole square. Let us solve few problems. First question, if the areas of two similar triangles are 64 cm square and 121 cm square, a side of a bigger triangle is 15.4 cm, find the length of the corresponding side in the smaller triangle. So let us draw a diagram. One small triangle and another one is bigger triangle. Area of smaller triangle is 64 cm square. Area of the bigger triangle is 121 cm square. So it is given that the side of a bigger triangle is 15.4 cm. Let EF is equal to 15.4 cm. So they are similar triangles. We have to find out the corresponding side in the smaller triangles. We have to find out BC. So they are similar triangles. It is given. Therefore, according to theorem 2.6, just now proved, area of ABC by area of DEF is equal to BC square divided by EF square. So substitute the values. Area of ABC, that is 64 divided by 121, which is equal to BC square by EF square. Now, instead of squaring this number 15.4 whole square, instead of squaring it, what we can do is we can take out the square roots from all the terms. So 64 by 121, if you take the square root, it becomes 8 by 11. If you take out the square root here, it becomes BC, that is BC divided by 15.4. So on cross multiplication you get 8 into 15.4 divided by 11. So 11 ones are 4 remains 4.4, that is 11 fours are 44, 4.4. So 1.4 into 8, so that is equal to 11.2 centimeter. That is the length of BC. Let's go to the next question. D, E and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratio of the areas of triangle DF and triangle ABC. Let us draw the diagram. ABC is one triangle and then D, E and F are the midpoints of sides AB, BC and AC. Midpoints. So join them, we get another triangle. Then what we have to do? We have to find out the ratio of the areas of triangle DEF divided by triangle ABC. Theorem 2.6 says, if the triangles are similar, then their areas are in the ratio of the squares of their corresponding sides. So for that, here we have to prove that triangle DEF and triangle ABC are similar. How can you prove? So we know that a line segment joining the midpoints of any two sides of a triangle is parallel to the third side and it is half of the third side. So here take any one DF or DE or FE. I will take DF. DF is parallel to BC and DF is half of BC. Or DF is parallel to BE and DF is equal to BE because E is the midpoint here. That means DF and BE, they are equal and parallel. That means BEFD is a parallelogram. The opposite angles of parallelogram are equal. Angle B is equal to angle F here. Angle B of the big triangle is equal to angle F of the small triangle. Similarly, DECF, it is also a parallelogram with angle C is equal to angle D, and ADEF is also a parallelogram. Angle A is equal to angle E. Therefore, those two triangles are similar. So now apply the theorem 2.6. So here B is parallel to BC and DF is half of BC. The line segment joining the midpoints of two sides of triangle is half of the third side and parallel to third side. So therefore BEFD. So all these are parallelograms. Just now I explained. Therefore angle A is equal to angle E. Angle A of big triangle is equal to DEF. It is the angle of the small triangle. Angle B is equal to F. Therefore according to AA criterion, using AA criterion we can write the small triangle is similar to the big triangle. Now apply theorem 2.6. So area of DF by area of ABC is equal to DF square by BC square. What is DF? DF is half BC. You can write here half BC whole square. DF square means half BC whole square. If you square the half, you get 1 by 4. So this is 1 by 4 BC square by BC square. You get BC square cancel out. Or you can write in the place of BC, BC is equal to 2DF. You can write 2DF here in the place of BC. BC square means 2DF whole square. 2 square is 4. So in the denominator, we have 4DF square, numerator DF square. DF square get cancels out. So we get 1 by 4. Therefore the ratio of area of triangle DEF is to triangle ABC is 1:4. So I have taken, in the place of DF I have taken half BC. DF is equal to half BC. It is squared. It becomes 1 by 4 BC square. BC square gets cancels out. So we get 1 by 4. Go to the last question. Corresponding sides of two similar triangles are in the ratio 4:9. Find the ratio of the areas of these triangles. The sides are in the ratio of 4:9. Therefore, their areas are in the ratio of their squares. That is 16:81. Consider two similar triangles. Let BC and EF are the corresponding sides. They are in the ratio 4:9. Let us take one is 4 centimeter, another one is 9 centimeter. So apply theorem 2.6. In the place of BC, write 4. It is 4 square divided by 9 square. So we get 16 by 81. That is 16:81. Dear students, so this is the question asked in the beginning. So now you can find out. These two triangles are in the ratio 1:9. Therefore, their corresponding sides are in the ratio 1:3. So 8 3s are 24. Here QR is 24 centimeter. This triangle and these triangles are in the ratio 4:1. 15 4 is 60. 4:1 ratio. So therefore, to get 4:1 ratio, if the first quantity is 8, first term is 8, the second term must be in the ratio, the sides must be in the ratio 2:1 according to theorem 2.6. Therefore, that must be 2 centimeter. So in the next video, we are going to prove the Pythagoras theorem. But to understand the proof of Pythagoras theorem, we need to understand one more theorem related to right angle triangles. So which says, if a perpendicular is drawn from the vertex of a right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Let us prove this theorem and stop this video. So drawing ABC is a right angle triangle with angle B is equal to 90 degree. So here is a right angle triangle. A perpendicular is drawn from the vertex containing right angle. So this is the vertex of right angle. A perpendicular is drawn here. BD is drawn perpendicular to AC. So that is the hypothesis part, assumption part. The conclusion part is we have to prove that the triangles formed on either side of the perpendicular are similar to the whole triangle and to each other. We have to prove that triangle ABD and triangle BCD, they are similar to the triangle ABC and similar to each other. So data, triangle ABC is a right angle triangle with angle B is equal to 90 degree and BD is drawn perpendicular to BC. So we have to prove that all these three triangles, the big triangles and two small triangles, are similar. So let us take one small triangle and one big triangle. Let us consider triangle ADB and triangle ABC. Triangle ADB is here, triangle ABC is here. So I will write those triangles separately. Triangle ABD and triangle ABC. So we have two right angles, a pair of right angles. Then angle A. So in this picture, angle A is common for both the triangles. So therefore, those two triangles are similar. So look at the answer. Triangle ADB is similar to triangle ABC. In the same manner, if we consider triangle BDC and triangle ABC, we have a pair of right angles. We have angle C as common. So therefore, they are also similar. So again, things which are equal to same thing are equal. So therefore, triangle ADB is similar to triangle ABC. Triangle BDC is also similar to triangle ABC. So therefore, all these triangles are similar. I hope you understood. Let us take questions for the assignment. Assignment number 4. If the areas of two similar triangles are equal, then prove that they are congruent. The triangles are similar, it is given. If the areas are equal, then you have to prove that the triangles are congruent. ABC and BD are two equilateral triangles such that D is the midpoint of BC. So find the ratio of the areas of triangle ABC and triangle BD. Dash is given. Justify your answer. So in the figure, ABC is a right angle triangle. Let angle B be the 90 degree. BD is perpendicular to AC. This is the theorem which we proved in just now. We have to continue that theorem. You have to prove that BD square is equal to AD into DC, AB square is equal to AC into AD, and BC square is equal to AC into DC. And this is the assignment for this video. So let us stop here. Thank you. Jai Sai Ram.